Introduction to Desktop Virtualization. Imagine that you are no longer afraid to run into an issue where your PC operating system comes to a halt and get completely corrupted and unusable. Envision that you want to test a software, but you are no longer afraid it will break into something into your PC. Picture this, running two operating systems on the same PC at the same time, or even different operating systems like Windows and Linux concurrently. All that and more is achievable via desktop virtualization. To begin, desktop virtualization is the process of converting a PC operating system into a single file. Imagine that you magically convert everything that is on your PC and copy it on a CD disk. That CD now contains a clone of the operating system with all your personal preferences and file and applications, 100% yours. You can then run your PC from that CD. Instead of doing a long and painful standard OS installation, you only need to run the virtual PC inside an application called an Hypervisor. Let's take an old desktop that we have at our disposal. It has a CPU with 4 cores, 4 GB of memory, 500 GB of storage, and an onboard graphic. The hard disk is formatted, but no operating system is installed yet. We can call this setup a bare metal configuration. This means that nothing can run until you install an OS, so only the metal is available, so to speak. The second type of hypervisor is a version that is installed on your operating system. This one is called a host-based hypervisor. This option is usually a preferred one for people who want to temporarily test a virtual machine and destroy it after a short period of time. The hypervisor will be responsible to assign the appropriate hardware component to our virtual desktop. There are many hypervisor models on the market. Some are commercial or enterprise level with licensing, and some are open source. Next step, we insert our virtual PC CD disk as explained earlier, and we tell the hypervisor to create a new virtual PC. In this scenario, the hypervisor will assign 1 CPU core, 1 GB of memory, and 150 GB of disk space, roughly 1/3 of the hardware we have at our disposal. We can repeat the same configuration with another virtual desktop, and we now have 2 PC, each running part of the hardware available. 2 PC for the price of one per user. Great. As we see here, we need to keep some CPU core, memory, and storage for the hypervisor to run. If we want to test an application and we realize later that it made some unrecovered change to our virtual machine that is now crashed, we can just delete it, retrieve the original state of our virtual machine, and start a new one fresh and clean. Let's summarize. The applications are installed on an operating system, each managed by the hypervisor that is installed on the hardware or bare metal. The last aspect that we haven't discussed yet is how we will see our virtual desktop. There are no display, mouse, or keyboard connected to our PC yet. First, we will need to access our virtual desktop via the network, in our case, the Ethernet connector. Now, to turn on the display, we will need remote graphic to the rescue. Using another PC or laptop, we can connect to our virtual PC via a remote communication protocol like Microsoft RDP, for example. We can access our PC anywhere without having to bring it with us. For more information about remote graphic, watch my other video on this topic. That's it. That was an introduction to desktop virtualization. Thank you.